Hello, everyone. We're going to wait a couple of minutes for other people to meet, and then we will start.
Massimo, can I ask a quick question?
Yeah, while we wait for people, yes.
Okay, so I just wondering, in the post-processing, we can for 2D elements, the STKO can help us to calculate the principal stress for the solid element, the plane strain element, but for 3D element, it doesn't provide this kind of option. Is there any reason?
No, the STKO provides principal stresses and stuff also for three-dimensional elements. The only problem is that I think you are using the PDMY material, right? Yeah, because when you ask for stress in a PDMY material, it gives you not only the stress, it gives you a vector of 7 components, the 6th component for the stress, and then you have an extra component for the G over G0. I don't remember what.
Yeah.
But since it is a vector of 7 components, STKO does not recognize it as a tensor. Okay. It's just so if you want to visualize it as a tensor in OpenSys, you can ask for material dot stress dot 6. If you put a 6, you're telling the PDMY that you only want the 7 components of the stress tensor.
Okay, I got it. So I just only need to do that, so then STKO can. Yeah,
you just go on the custom results because it is not among the built-in results, and you type material dot stress dot 6.
Okay, I see. Oh, okay, I see.
Or I don't remember if it is material dot stress dot 6. Yes, with a dot. We can do a test anyway.
Okay, yeah, I see. Okay. Thank you so much.
You're welcome. Okay, so I think we can start. We can start because there is no one else joining. Okay, so I share my screen. This one will be a quick webinar, and then if we have time, you can ask some questions. Okay. So I don't know if you already have downloaded version 3.0, but anyway, this is the changelog. Well, there were also some bug fixes, but the main things are the new improvements. Okay, so we have some new features in terms of the components that we have. For example, the MVL and SFE multiple vertical line element, or the gradient inelastic beam column, few others material like the multiplier material. This is not so important. I want to focus instead on the new feature we have in the STKO processor. Okay. So we made a lot of changes in the post processor, and now you can interact with the model much easier. So for example, here I can load, let me go full screen first. Okay, now I load a simple model. We are not going to do any analysis in this webinar. I just want to show you the new features, okay? So imagine you have a quite complicated model, for example, in this case, a bridge, a real-life bridge. So you need to have different components. In this case, we had a lot of isolators, a lot of physical properties, because you have to represent the reality. So you have sections which are slightly larger than others, okay? So when you do a real-life model, you end up having a lot of components in the work tree, in the preprocessor. And so sometimes also a lot of boundary conditions, finite elements, and so on. So when you want to post-process this data, sometimes you may want to isolate only some components based on the location they have, based on the material property you assign, whether it is a column or a beam or a slab or an isolator in this case. But the problem is that when you are in the post processor, okay, so basically this is what you have in the post processor. In the previous version, if you expand the database node, you only have the list of results that you asked for. Okay, so it's just for results, but you cannot interact. You can do everything here. So, but let's imagine, for example, you want to isolate some columns. It is pretty easy because you can select them, okay, and you can isolate them like this. You want to select, I don't know, all the isolators. Here we have isolators. Isolators here, it can be very difficult to go and select every one of them, or only some of them based on their constitutive models, okay? And so what we did basically is that if you create a model with the STKO preprocessor, okay, you can have some extra data. Okay, so when you expand the database node here, you not only have the results nodes, but you also have a lot of information coming from the preprocessor. So for example, selection sets. You have a reference to the selection set you have in the preprocessor. Okay, so in the preprocessor here, I had two selection sets. In this case, I had, if I remember correctly, a set for nonlinear elements and another set for linear elements. Yeah, in this analysis, I needed to assign different Rayleigh density to them. Anyway, if you have some selection sets, you can create them here so that in post-processor, you can use them, as you can see here, select only that component, and you can isolate them, and so you can work with them. So it will be very easy for you to identify some components that you have in the preprocessor, and you want to see them in the post-processor. So without going into the graphic window and doing the manual selection, okay? You can go through the selection set, select, isolate, and you're done, okay? So you have the information from the selection set. Then you have the physical properties. You basically have all the physical properties here, but actually not exactly all of them. You have only the physical property that have been assigned to the element, okay? Because actually it was not necessary to have the physical properties not assigned to any element because you don't need them. Okay, so for example, if I want to select all the peers, in this case, I can go here, select, and I have a selection for my peers, okay? Same thing for the header here, and isolate them, okay? I can quick restrict the view, the graphic view to the element that I want, or the DAG property, select, okay? I can isolate it. And then for the isolators, for example, in this case, I had, in my model, I had 4 kinds of isolators. Now let me, since the isolator has 0 length element, they are more visible if I switch on the node. Let's say, for example, I want to do some post-processing with the isolator of type 1. So isolator T1 is this, I select it, I isolate them, okay? And I have a quick selection of what I want, okay? So it makes the post-processing much easier and much cleaner. So physical properties, then you have the same thing for element properties. Now in terms of element properties, this model was very simple. You only have beam elements for beams and columns and 0 length elements for the isolators. Then you also have something else which is not in the STKO preprocessor, but comes from OpenSys, which are the solver elements, okay? So for example, here you have a selection set with the name of the solver given by OpenSys. So for example, my isolator, which in STKO has been called isolator, but actually it is a 0 length element, okay? So if I go here, edit, it is a 0 length element. In the post processor, it gets the name directly from OpenSys, which is 0 length, force beam column, and so on. And then you have geometries and interaction, okay? So here I have 4 geometries, which is basically the same thing I have here, okay? My geometries, except from these support points, because they are not translated into an OpenSys element, okay? So only the geometries that were translated to OpenSys elements. So in my case, I have piers, I have the deck left, right, center. Let me see, I have deck left, right, center, and then piers. Okay, all these others are the nodes for the isolators. Okay, and then I have the isolators, which are the interactions. So if I go here, I also have interaction, and I have all my isolators. I have the isolator number 1 on the left, Then I have isolator number 1 on the right, and I can select them. It will be very easy. For geometry, I have the entire geometry like this one, for example, the deck on the left side. Okay, or I can expand the geometry node and I can have the sub geometries. Okay, pretty much like in the preprocessor. So deck left has, I don't know, 8, 9 edges, and I go here and I have the same 9 edges. Okay, and I can select all of them. For example, I want to select only this one, isolate, and I have it here. Okay. So basically you have all this information. Now, let me go back to the improvements. Okay, so the work tree in the post-processor now has model information coming from the preprocessor. Okay, so this one is the main new feature that you can use for isolating stuff, for creating selections and so on. For those of you who are already starting using the Python API, all this stuff has already been exported to the Python API, so you can perform these selections also from Python. Then the second point, plots can be shown, hidden, or locked, unlocked from the work tree. Why? Well, imagine I want to superimpose. If you remember, in a plot group, you can have one plot or multiple plots. So sometimes you may want multiple plots because you want to superimpose them. Like I want to have a displacement plot here. Okay, and then I also want a deformed shape. Okay, to see what is the reference geometry. A deformed shape, which is example. Okay, so let's imagine now that I want to perform selection as before. Okay, so if I go on, I don't know, selection set, nonlinear set, I click here, select. By default, I select them in all the plots. Okay. Now, sometimes this is not what I want. For example, I want to select things only on one processor. But this is the same, for example, if you perform the selection manually. If you do something like this because you want to isolate this part, you end up selecting all the plots. Okay. So now we have a new feature, which is called the, here you have the lock button. So for example, if I want to select stuff only on the surface color map, but not on the deformed shape, I can simply lock it. Okay. So if I lock the surface, the deformed shape, and I perform a selection here, I can only select the surface plot. Okay. And I can, for example, I can hide it, keeping the previous plot visible. Okay. So sometimes, many times when I want to isolate parts of a plot, it was difficult for me because I was selecting also the other plots that were superimposed. Okay. So it was a mess. Now with this thing, you can avoid selection. Otherwise, you can hide a plot. So many times, for example, you create many plots, but then you want, just for doing comparisons, for example, then you want to produce an image for a report, and you don't want a plot anymore there. Okay, so you are forced to delete the plot, but maybe later on you will need it again. So now you can simply, okay, so now you can simply hide or show a plot. Okay. So this is the other feature. What else? Plots can now be shown, hidden, or locked, unlocked. Okay. So point number 3, oh, the color bar. Yeah, the color bar in the plots can now be edited and moved. Okay. So this one was another problem that we had when we were superimposing many plots in the same plot group. Okay, so for example, now I don't need the deformed shape, but let's say, okay, I have a deformed surface color map for displacement. Then I want to superimpose a beam fiber. Now the beam, here I selected the beam strain, and in the beam strain you see that the name is very long. Okay, so if I create another plot now, for example, a Gauss plot for the isolators, the material strain in the isolator, you see that now the color bars are occupying pretty much the majority of the window. This is pretty annoying. Okay, so now in the current version, you can edit the color bars. So for example, if I want to go here, the color bar of the fiber strain, I go here in fiber color map, and here I have a button called Edit Color Bar. I click this one, and I have some options, okay? So the first one is pretty simple, visible or invisible or not visible. If I uncheck it, okay, that one will be hidden, and then the other color map soon gets replaced here. Or otherwise, I can show it, but I can change the name. For example, in this case, the name is very long. I want something easier, just to produce an image for a report, for example. I can go here, custom title, and I can write fiber strain, just fiber strain, for example. I can change the subtitle. I don't want epsilon, but I want just E11. I can change the font. I can make it smaller. I can make it larger. Okay, so you can customize it. And then you have the position. Now, by default, in STKO, every color bar is anchored, is automatically anchored from the top left corner. Okay, so they are positioned in a stack. Okay, so at first I place the color bar of the first plot, then the second, the third, and so on. Now, if you remove the auto anchor, okay, you can manually specify the location. Okay, so in Y, or you can go down in Y. Okay, or you can change it for here. You can change it from the X direction, or much easier for positioning, you can do it manually. So now, if you can see, now I can highlight or select it. So I can select it and I can move it. Of course, for doing the selection, I need to pass through the color bar rectangle. Okay, not on the text, not on the numbers, just on the rectangle. When I'm here, I click, I hold the left mouse button down, and I move it. Okay, same thing for the others, and I can arrange them as I want. Of course, I have some constraint. I cannot go outside the graphic window, but I can move it wherever I want. Okay, so this is also very, very useful for creating plots. Of course, when you have many superimposed plots. Okay, and what else? Oh, and the animation. Yeah, the animation of a plot group can now be either time history based, as in the previous version, or scale factor based. What does it mean? Let's go back. Let me remove these plots. Okay, now in the previous version of STKO, the only way for animating a plot was through time history. Okay, so you didn't have the opportunity to choose what kind of animation. So basically, the slider refers to the time step. Okay, so when I'm here, I am in the first time step, and when I move it, I will go into the proper time in the database, get the result, and plot the data. Okay, and the deformation of the plot is decided by the deformation in the editor. Okay, so I can make it 20, or I can make it larger. Then when I move this one, I will just move in time. This is called time history animation. Now, some users have been asking, okay, but what if I want to animate the plot of the eigenmodes, for example? The eigenmodes do not have a time history. They have just one fixed time history, but I would like to animate it like changing the scale factor, okay? So that I can see my structure moving, but not in time. In a fixed time step, I just want to move it by changing the scale factor. So now you can do it. For example, let's say I want to fix everything at the last step. Okay, so I'm here at the last step. I don't want to do a time history animation. I want to do a scale factor animation. Now imagine this is a plot of an eigenmode. I can change the minimum and maximum scale factor. For example, I can go from -100 to +100. I can choose how many frames, because of course now it is not a time history, so I do not know in advance how many frames you want. You can choose it, and then you can move it. Okay, so if I go here to the center, it will be deformation of 0. If I go back here, I will go to the minimum scale, and then forward to the maximum scale. Okay, or you can make it 0. You can move from 0 to the maximum scale, and you can perform an animation like this. Okay. You just animate basically the scale factor amount. If you want to make it faster, you can just change the number of steps, like 50, and then you do a loop, okay? So this one will be very easy for animating eigen modes, for example, which was not possible before. What else? Yeah, so for the post processor, it's everything, okay? So basically, we didn't add a new feature, we just add some utilities for making the workflow much faster, much easier. And now we have another feature that many of you have been asking, the autosave feature, okay? Because sometimes you are working for many hours on a file, you forget to save it, and then for some reason you have a crash and you lose that file. Now in the preprocessor, we have the autosave feature. Okay, now I will explain you how it works. So I don't need this one anymore. When I go here in preprocessor, if you go on home, next to the save buttons, you have the setup for the autosave. Now by default, it is enabled, okay? And the interval is, I think by default, it was 20 minutes, okay? Now, in this specific example, I will change it to 1 minute just to show you how it performs autosave much faster. Okay, so for example, let's say, one thing I want to tell you is that the properties that you change here are not local to the document, but they are memorized in your computer, they're stored in your computer. So for example, if I disable, let's say I enable it, I want to make it every 1 minute, okay? I close STKO. Then when I open STKO again, you see the settings are the same, okay? So they are not saved inside the document, they're saved inside the application. Perfect. So now I have an autosave every 1 minute. Now I want to show you how it works. Now, first of all, I want to show you where is the folder where you have the autosave backup files, okay? Now, the autosave backup files, you can find it in, if you go on the Explorer, you go on this computer, the first hard drive, then you have users. Sorry, this is in Italian, but this one is users, okay? You can see here, see users. Then your name, the user you are using, in my case, it is Max. And then you have a hidden folder called app data. If you cannot see it, you can change the settings to visualize the hidden folders, right? Okay. So if you don't know how to do it, you can go under view, you have options, and under the option, you can change here in visualization, there is a button here, show hidden folders, okay? So if you don't see app data, you can go there. Okay, now that you have here, you go in app data, and you have 3 levels. In STKO, we save things in local. Okay, so once again, see users, the username, app data, local, ASDEA software technology, STKO. Okay, so this is where we save our own stuff. Now, particularly the backup file, they are in a folder called backup. Okay, now I want to show you how it works. Now, to show it to you, I want to make this window here. Actually, it is not strictly necessary to understand where the backup files are, but it's fine if you know it. Okay, so if for some reason you need to find manually the backup file, you know where to find them. Okay, so I put STKO here and the backup window here, so that you can see what's going on. Now, of course, now I'm not saving anything because this file is empty. But as soon as I create a geometry and I make the file modified, like for example, I put a point here, now my file is modified. Now you will see that in a minute from now, because here I have 1 minute, some file will appear here. Okay, so let's wait a couple of seconds. Of course, in real life, don't put 1 minute because it is too fast. You can put 10 minutes, 20 minutes. Okay. But this is just for showing you how it works. Okay, so you can see here, I have a first autosave, and now there will not be another autosave because now the file has been saved already in a backup file. If I do another change, then I will trigger another autosave. Now for each file, you will see a back file, which is the exact copy of this one. Then you have an info and an image. I will tell you what it is. But then the file has the same file name here. In this case, it is a new file, so the file name is untitled, plus a unique string that makes it different from any other file. Okay, then what happens? If you close the file, or if you save it, or if you close STKO, this file here will be closed, okay? Because you have the file here. So for example, I want to save this one on a new folder, like here, XXX, save. Okay, so my file has been saved, and now I don't need the backup file anymore. So they are not there anymore. Now what happens? Let me do another modification. That is called XXX, this file, okay? Now I do another modification, like I create a line here. Okay, now my file is modified. Now we wait 1 minute, and in 1 minute, I will see another backup here that now will be XXX, then the name of the backup file. And then I will show you some stuff. I will show you what happens if I make the application crash. Okay, let's wait a few seconds. Now we should see another backup. Okay, now I have another backup here with the name of the file, the unique string, and all the stuff. Okay, now as I said before, if I save the file or if I close STKO manually, so it means everything is fine, the backup folder will be empty. But if for some reason you have a crash, now of course I cannot wait the application to crash because it cannot happen. I have a function here that will force the crashing of my application. Okay, so if I crash my application, you will see that this file will remain here. I run this one, this made my application crash. Okay, now since it has crashed, it didn't delete all the backup files. Now what happens is that when I open STKO again, he will tell me that, you see, so now STKO is open. He checked the contents of the backup folder. He found some file, and then he tells me, okay, after a previous cache, STKO has detected one unsaved file. Do you want to start the recovery process? And then there is a warning. If you don't, you will not be able to recover the file anymore. Okay. So for example, if I click on, let me go here to the backup file. If I click on cancel, I will delete this one and I will not recover it. So it's always better to click OK. I want to start the recovery process. Then for each file that I have a new window. Okay, for example, recovery file 1 of 1, because now I have only one file. It tells you the name of the file, the suggested recovery directory. So where STKO suggests you to recover this window, this file, that by default basically is the same folder the original file was created into. Okay, and then you have a preview of an image of the graphic window at the time the autosave was taken. Okay, so that at least you understand what file it was. Okay, so you said, okay, yes, I made this modification of this line and I want to recover it. Okay, then I press yes, and then it simply asks me to save this file with another name. Now I want to replace the original file. Yes. Perfect. Now open STKO is open. Now I can open the file that I recovered, and I will see the modification that otherwise I would have lost without the autosave process. Okay. So the autosave is fine. It's pretty easy to understand. I just want to show you something because we have seen people that are used to launch several instances of STKO on the same computer. Now, this is a bad habit because actually in Windows applications should be with a single instance. But then what happens if I open many STKO instances. The problem is that, as I told you, if I create a modification now, I modify this file. Now in 1 minute, I will have the backup here. Okay, so let's wait 1 minute. Okay, now I have my backup here. Now the main problem is that in the logic of the Autosave framework, when STKO opens, and if it finds an existing backup file, it will tell me that there was a previous crash, okay? The problem is that what happens if I open another STKO window while STKO is still open, okay? So the new window will think that these backup files are there for a crash. Instead, they are not there for a crash. They are there because there is another STKO open, okay? So in this case, I will press cancel. Now we will fix this stuff in a future version, in the next release, because actually it's not something that I typically do, okay? I typically use only one instance of STKO on each computer, but we have seen users that are used to open many STKO windows. And this habit of having many STKO windows will not work very nice with the autosave feature, okay? So for the moment, you can do it. Just remember to save many times your file. In the next version, we will create a backup file for every STKO instance, so there will not be any problem. Okay, so this is all for the backup file, for the autosave feature. Okay, so these are basically the new feature. As I told you, this is not going to be a very a long webinar, very quick webinar. So now if you have question about the new features, or if you have any other question, we have another 30 minutes because the webinar should be 1 hour, but as I told you, this one is quite quick. So we can do a question and answer if you want. Okay. So please, you can switch on your camera, you can start asking questions, or we have something in the chat. Oh, updates on importing TCOL. Yeah, we can talk also about it. We have a TCOL import, a very small TCOL importer, but the problem is that, it was a company that asked us to create a small TCOL importer, but it was limited to their needs. Okay, so importing a TCOL is not an easy task because you should replicate every OpenSys function and change it to an STKO geometry. So it is not something that we are going to do in the near future. We are working on it. Basically, what we will do in the, I don't know if in the next version or in the other one, we will present in a webinar how to create a simple TCOL importer for few finite elements in OpenSys, like a couple of material models, couple of beam elements that you can use as a base to create your own TCOL importer, okay? Because otherwise the problem is that if you wait for us to create a generic TCOL importer, it will take not months, it will take years, because it means go inside every OpenSys function and create a duplicate of that function for OpenSys, for STKO. Now imagine that OpenSys has more than 200 material models, few hundreds of finite element models, and then you have all the analysis steps, all the settings. There are more than thousands of functions. So it is not something that we will be able to do in the short term. So the idea was that in some of the next webinars, we will present a very basic TCOL importer, and we can start working on it. You can start working on it, you can contribute, and then we can make it grow, okay? Okay, so we have, if you want, you can ask questions with the microphone if you prefer. You can switch on the camera. You can ask all the questions that you want if you prefer. Otherwise, we can use the chat. It's the same. Okay, so we have a question from Maria Victoria. What about the possibility of changing master slave nodes when you define an interaction? I always confuse nodes and I have to repeat the action. I haven't updated the version recently, so I'm not sure if it is implemented. Actually, I can show you something because this was something that we wanted to do. Also, let me show the screen again. It is in the change log in the to-do for the next version 3.1. There are something we want to do on the interaction. So we want to skip, well, this is not important. We want to make an interaction two-sided. This is for contact, so I'm not going to explain you what is. We want to swap master and slave, but we also want to color master and slave differently so that you can visualize who is the master and who is the slave. So if you realize that you made a mistake, you can swap it. We wanted to add it in the current version. We didn't have time, so it will be in the next version. Okay. Okay. So next question. Regarding the ASDEA embedded node element for UP element, what is the value of KP? Okay. Yes, there were some users asking for this feature. I don't know if it was you, but probably yes. Someone on the forum had a problem using the embedded node element for connecting soil elements using UP elements, so elements with the pressure DOF. Okay. Why? Because when I coded the ASDEA embedded node element, the pressure DOF was not taken into account. Okay. So basically the displacements were connected, but there was a disconnection in the pressure, and this made the application unstable. So now this is a good question. What is the value for KP? So what is the penalty for the pressure? Actually, it depends on some settings that you have there, but I've seen, and we will make a webinar of that. I've seen that a very small value of this will work. Let me see if I have an example here, because I've seen that it is very unstable. So if you use a very large value, it will create numerical problems. Because actually, I went into the source code of the UP element, and the problem is that they add the displacement pressure coupling only in the dynamic matrix. It's only on the damping matrix. It's not on the stiffness matrix. So when you add a very huge value in the stiffness matrix, it creates some problems. If I remember correctly, I did a test and I wanted to show it to you in a new webinar. But let me see if I can find it. There was not the constraining question element. I don't remember if I did it here or not. Or probably it is in the forum. Let me see. Well, anyway, you have to use a very small value. I think if I remember correctly, it was something close to the permeability coefficient. But you can do some tests, okay? So if you want, you can create a file with this one, start with a very small number, like 1 to the -3, and try to see how it changes, okay? I did some tests, and I can tell you that a very large number for KP is going to be a problem, because actually there is not a stiffness for the water pressure. So start with a small number, plot the profile of the pressure, and see if it is continuous through the two domains, okay? It should be continuous. I think that with a very small number comparable to the permeability coefficient, it was fine. Okay. It was you that had this problem in the forum, because there was some user in the forum that was trying to use the embedded node element with UP elements. I think it was, yeah, I can also show the forum probably. I don't know if it was you or not. Yeah, it was you. Okay. So this is something that we can do. I don't know if I sent you something, but if you want, make another question in the same post on the forum, so that basically in the next week I can answer it with an example file. Okay. But please make a question so that I receive a notification. Okay. Any other question? Yeah, you're welcome.
Yeah, it's me, Victoria, again. Hi, Massimo. I have another question, which is more complicated, so that's why I decided to switch on the microphone. So the thing is that when I try to perform loss assessment in MATLAB, I compute, the results from STKO and so on. So the thing is that for me, it's quite complicated to find the element in the mesh of STKO. So yeah, so I was wondering if you have been thinking about the possibility of naming the elements or the nodes following a procedure. For example, the column in the left part of the plan is column 1, 2, 3, 4, 5. Because I know that the I don't know if I explain it.
Yeah. Basically, what you want to achieve. Actually, I can tell you that we cannot predefine the numbering for the nodes, because actually it depends on the mesh algorithm.
Yeah, I understand. Yeah,
that can be a problem, but probably you can solve it in a different way. So you told me that you need. So you can explain me what you need to do in the end, and I can tell you if there is a better way for doing it. So you told me that you are doing some post-processing in MATLAB.
Yeah. So I need to define the drifts, the displacement, and so on. So I need to, instead of using the post-processor of the STKO, I just write the recorders in as a custom command in the analysis steps. And I need to define the nodes and the elements for which I want to obtain the results. And I have to put the ID node, the ID element, and for me, it takes a little bit. It takes a while to find the ID of each of the columns or each of the nodes. So
the problem is not in the post-processor; it's in the pre-processor.
Yeah, it is in the preprocessor. Yeah, sorry.
You need to do something different. You need to make it automatic. Like, let's say, for example, let's create another. I want to open another stuff like, let's say, a bridge model, like this one. Let me do a quick modification to this. So let's say you told me that, for example, you want to create a recorder. Let's say, for example, on this column here. Okay.
Mm-hmm.
And maybe this column is divided into multiple columns. Okay. Mm-hmm. So you want to record everything, and you want to remember who is the position and stuff. So what you can do actually, well, one thing is to create the mesh. Go here, but this is pretty annoying. Visualizing the data. So, for example, this node, the data for the element.
Yeah, this is the process that I follow. Yeah.
And this is not nice. You know why? Because it is fine if you know that you are not going to change the mesh. But let's say, for example, now this element here, or the element on the top of this column, or let's say the element at the bottom. Okay, element at the bottom is the element number 9 or the element number 69. But if I change my mesh and I say global seed uniform by size, oh, this was in meters, I think. No. Yeah, it was in meters. Let's say now I want to create it every 1 meter. Assign, done, build mesh. Now this element down here is not anymore 69, it is 449. Okay, so this is not feasible. You have to do something different. So let me go back to a small mesh. Say 5 meters. Even larger. Maybe by size. Okay, done. Mesh. Okay. So let's say I want to record always all the elements here on this column, okay? Without knowing what is the ID. Or actually even better, now create only one division per part. Okay, so it's much easier. Okay, so the first thing that I can do is to create a selection set. So this one is one of the elements I want to record. Okay, and let's call it E1. So for you, this one is element 1. Okay, it should not exactly correspond to the OpenSys element. For you, this one is the element 1. Okay, so now you go here in the analysis steps and you create a region, like region E1. Pattern, add pattern, no, sorry, miscellaneous command, region. Now you can do something like, yeah, E1. If you want to record the elements, it can be a recorder type, it can be a region of type element. If you want to do a node recorder, you can change it to nodes, okay? Optionally, you can write the list, the TKO list, like list E1. Okay, and this is fine. You can do this, you move it on the top, and then you can create a custom command for the recorder E1. Miscellaneous command, custom command. Okay, now it depends on you. For example, what do you want to do? For example, you may want to create an element recorder for each and every element in that selection set, for example. Is this something that may work for you?
Yeah, for example, obtaining the forces, you know, element force.
For each element of E1, for example. Okay, so you can do something like this. Set an L like list length of the name that we give to the previous length, to the previous list was list E1. Okay, now the previous region command, what it did was to create a TKO list called list E1. But of course, to do this, you need to switch on this option, write on list. So this one will create a TCL list containing all the elements in this region. So if you need to use the OpenSys region, you can use that. If you need to loop in the TKO list, you have it. You can define it and you create a name. This one will be the name of the variable associated with that list. And then you create your recorder here. You can say, okay, first I want to know how many elements I have in this list. Then I say, for example, for set I0, I less than number of elements. Increment I. And then you can create the element recorder for I, like recorder element file. The file can be, I don't know, in this location, it can be E1 underscore the ID of this element, okay? Now, in your case, you only have one element for the selection set, so you only will see E1 dot txt, for example. And then you have to specify what is the element, so L and list L index. The list is list E1 and the ID is 1, okay? Because now you are doing a loop in this list. Okay, so this one gives me, sorry, not this one. This one gives me the real index in OpenSys of the element, of the current element. And then the output, for example, local force. Okay, is this fine for you, for example?
Yes, it is.
Okay, so let's press OK and let's see if it works. Of course, you have to move it before. Okay. Let's run it. Okay, I made a mistake. Error copying. Oh, this is another stuff. Sorry. I need to close this one. This was not due to that. what is the, I think I wrote it in a, yeah, in a, what is it? In a protected folder. Let me create a protected folder here. Let me delete this one. Okay. Unfortunately, I copied it from a protected folder and it remained protected. Okay, so run it. Okay, so here I created a problem. Tag 15 already exists. I made a mistake here, so I changed something. But anyway, here I made another mistake. Let's see if the recorder exists. E10. Okay, so this one is the output for the first 10 steps of your element. Okay, so you can do something like this if this works for you. Okay.
Yeah. This is exactly what I do, but I did it just checking the IDs of the mesh.
The thing of this approach is that you don't need to know what is the element ID. Okay, you just need to create a selection set in STKO. Or for example, let's see what happens if I remesh it. Like I go in mesh, global seed, and I say division 2. Now I should have two files, E10, E12, E11. Same thing, it was still protected. Let me remove it. Is it? Oh, once again. Oh no, it was the recorder. Sorry. Okay. Okay, same error as before, but now I should have two files, E10, which is the bottom element, E11, which is the top element, if the element is directed into this direction. Okay, so for example, you go here, your selection set was this one, select. The orientation is, let's isolate it. The orientation is going from the bottom to top. Okay, so let's make sure, for example, I have E89, which is the first one, E90, element 90 is the second one. So in my OpenC, my TCO script, what I should have now is, let me find recorder element, should be at the very beginning. Okay, list E1 is 89 nines. Okay, so it is following the direction of the element, right? So that basically what I do here is that for E equal to this one, I loop in every one of these lists and I create a file. So E0, E10 will be the first one. E11 can be the other. If you want to know the real index, you can do something different. For example, now I created a script that does not tell you what is the ID of the element in the file. But if you want, you can do something better. So instead of I, you can put the element ID, like set LID equal to this index. Here I put LID. Okay, so that now I can use the element ID directly here instead of I. Okay, so that now the element, the OpenSys element ID is attached to the file name. So probably it's even better. I run it now, but before I need to remove these things. Okay, let's see if it works. Okay, so this one were the previous files. These are the new files. So E189, E190. Okay, so you can play with it, but the approach should be this one. Okay, so you create a selection set, you create a region, you write the region into a list, and then you have your own custom script. Okay.
Okay, thank you very much. That is going to save me a lot of time.
Okay. Well, probably in the future we will create some extra features, but yeah, you can do it with TCO scripting. You can do it. Okay, we have another couple of minutes if there is a last question. I think yeah.
Massimo. So like I have saw the like in the forum there's a problem about the seepage analysis, and I think that is really important for the geotechnical group. So I saw that you mentioned that maybe in the end it can be a built-in function in the STKO, and I agree with that, and I think it's really important for us. But I'm just wondering because in the forum, the STKO team only provide the solution for a single processor. But will it possible to provide a couple of an example for the user using OpenSys MP?
For what? Can you send me the link to the forum that you're referring to? Because I did not understand what is the topic you're referring to.
Yeah, there's a seepage analysis, and it's about like to define.
The seepage analysis. Okay, yeah. Yes. Actually, I answered only for the sequential version because it was easier to write, just to explain the user how it works. Okay. I can do it for the parallel analysis. The only problem is that when someone will ask me to do it, I will do it. Okay. So if you want, you can ask it on the forum.
Okay.
And I will do it during the next week because now I'm pretty busy. Basically, the concept is that the algorithm is the same. So when you do the seepage analysis, what I'm doing is that I'm fixing or releasing some of the pressure drops, and then I perform. It's like the equilibrium iterations. Okay, so I perform an error norm. I do a test, and if it is fine, I do not proceed with the next iteration. Otherwise, I do it. Now, the only problem is that when you are in multiprocessing, you need to do this iteration in every process and make sure that it converges in every process. So there is a little bit more complicated because I need to perform message passing through the different processors. So basically, each processor should tell the other processor if they converged or not. So it will be a little bit more complicated to write, but it can be done. Okay.
Will it possible like you just like when we use preprocessor and we can just like plot a line like for the groundwater level, and then we can define a certain area like we want to fix the pore water pressure to 0. So when you generate the TICO file, it could automatically recognize which node I should just fix.
But that is what the script in the post is doing is that you don't have to provide anything because it will fix automatically every pressure drop which is negative, basically. So iteration, if a pressure drop is negative, I fix it and then I perform the extra iteration, and then I stop when no pressure drop is negative anymore. Okay, so basically you don't have to provide anything because it will find the points to fix. Or actually, this is the suggestion that the user gave us, but actually I don't know how to perform a real seepage analysis, so probably there is a better way for doing it.
Just because sometimes the groundwater level will be so complicated, it won't be just a high level and low level. Maybe there's some intermediate, like.
Okay. Yeah. So you said not doing that.
Yeah. So like for now, like when I try to do that, the only thing I can do is to just like to create several selection set and output those TICO files and use Python or MATLAB to pick up those nodes for me and create another TICO file to fix the pore water pressure for those areas.
But actually, what you need to do in this case is not the seepage analysis I did in that forum. If you want to make it programmatically, you always need to write a script. So probably in the future we will do it. But what you can do, if it is in 2D, it's very easy. If it is in 3D, a little bit more complicated. But if it is in 2D, it will be pretty easy for you because you can draw, for example, the point is that you need to have the points defining your water level, okay?
Yeah.
You need to have them ordered from X to X minus to X plus. And then you can perform, actually it's very easy because you can, for each point that you want to test in your mesh, you find what is the segment of the line it falls into, okay? Okay, you may say, okay, it falls between point 1 and point 2, okay? You compute the line between point 1 and point 2 and you perform an intersection between a vertical line passing through the mesh point and this segment. If the intersection is true, if the distance is positive, it is on the upper side, so should be fixed. If it's negative, is on the downside. So it's very, actually, it's not so complicated. You can
it's just because sometimes when we use 2D element, you need to be like a square shape. So
yeah, I understand what you mean. So probably what we can do is to create a Python utility that basically the user can create a line and automatically fix everything which is above that line.
Yeah. That would be
okay.
Yeah, just a minor suggestion, and thank you.
Yeah, you're welcome. Okay, so thank you everyone. Oh, the last thing that I wanted to show you, that will be the topic of the next webinar. It will be, the next webinar will be in 2 weeks from now, is that among the other things, we now have the, do you remember that in STKO, all these things here from definition down to the analysis steps are in Python, they are open source, they can be programmed by the user. Now they are on GitHub. So if you go on GitHub and search for ASDEA software, so github.com ASDEA soft, this is the web page on GitHub of our company. There are some projects which are private, so you will not be able to visualize them, but the external solver of STKO, it is public. So you will be able to go here and you can create some issue here. You can ask people to do something. If you want, if you know Python and you want to contribute, you can do it. You can create pull requests pretty much as you do in OpenSys, okay? You can visualize the source code and you can do all this stuff here. Now, this is for programmers. So if you know Python, if you know how GitHub works, if you know how the external solvers in STKO work, you can contribute to that, okay? This will be the topic for one of the topics of the next webinars, and I will show you how to interact with the Python API here, how to create new elements and new stuff, new automations. For example, the one that you were suggesting, UA, so the automation for creating the seepage analysis, and how to contribute to STKO, okay? So this will be the topic of the next webinar. And that's all for today. So thank you for joining this webinar. Hope you enjoyed the new version. And yeah, see you in 2 weeks, okay? Bye everyone. Thank you for joining the webinar.